in this video, we're going to talk about topic 6.1 and 6.2, and we're going to look at left Riemann sums. So we call these left Riemann sums or left rectangular approximation method. We can abbreviate that LRAM. So what I'm going to do is I'm going to start by drawing my rectangles from the left. So notice my first height's kind of there, my next height's there, my next height's there, and it says I have to do five subintervals. Talk about the number of subintervals. My next height's there, my next height's there. Okay. So I'm going to try to find the areas of all of those rectangles. That's what I'm going to do. So I'm going to basically put my values into this function. So let's think about that function in terms of a table for just a second. So this is x and this is f of x. So if I put my first height in of 0, and then I said it was 1, 2, 3, 4, right? I didn't actually draw a height from 5. So if I put those values into here, it would be 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 5. So what we're really going to do is we're going to find the areas of these rectangles. So I'm going to say that LRAM, I'm not writing that very well, LRAM equals, and if I look at this first rectangle, technically it has a height of 0 and a width of 1. So I would do 0 times 1 plus, then I've got a height of this 1, right? That's the height, and again, the distance in between is still 1. So it'd be 1 times 1. And then, again, this height would be this 4, and then my distance in between again would be 1. So I do 4 times 1. And then my height on this one here is 9, and my distance in between is still 1. So 9 times 1. And then finally my height on 4 that we calculated was, oh, it's not 5, is it? What did I do? 16. 16 times 1. So 16, and then my distance in between is still 1. And then I multiply that together and I add it up. So I'd really have 0 plus 1 plus 4 plus 9 plus 16. When I add all of that up, I get 30. What I want you to notice though is, if I were looking at this function and I'm looking at it, and the next question is it an overestimate or an underestimate? Well, in this case, because there's gaps in there, I know so I have some area underneath the curve that's not filled in. This would be an underestimate. All right, let's take a look at example 2. Now, Delta Math is going to write this a little bit differently when you see the assignment in there. So they're going to give you the instructions, and they're going to say something like this: from 0 to 4 of x squared plus 3 dx, and then they're going to say, hey, you need to divide it into 4 equal subintervals. So it is just, this is notation. It's called an integral symbol. We're going to get more into that later. I don't want you to focus on that. So the way that you deal with this when you see it like this is it's just like having this and you have to calculate this. So you take these numbers and you subtract them. So to get the number of subintervals, width of subinterval, not number of subintervals. So width of subinterval. And so you're going to do 4 minus 0, and you're going to divide it by whatever your n value is. So that would be 4 minus 0 is 4 over 1 over 4, and that's going to equal 1. So I know the width of my subinterval is going to be 1. I am still going to set up my table of values, but I'm going to practice drawing my rectangles one more time. So I know from the left side, I would come up till I hit the function and draw it over. Up till I hit the function, draw it over. Up till I hit the function, draw it over. And I know I've got to stop when I hit 4 because my interval will go 0 to 4, or if you're writing it like this, 0 to 4. Up till I hit the function, draw it over, and I'm stopping. Okay, so I'm going to do a little t-chart again with my values. So x, f of x, and I know I've got 1, 0, 1, 2, and 3 this time. All right, and then I'm going to plug them into here. So x squared plus 3. So 0 squared is 0 plus 3 is 3. 1 squared is 1 plus 3 is 4. 2 squared is 4 plus 3 is 7. 3 squared is 9 plus 3 is 12. Okay, so now we're going to talk about our rectangles, bases, and heights. So typically what I actually like to do is when it tells me how many subintervals there are, I set up for that. So I'm saying that it said it had 4 subintervals. So I'm going to draw places for 4 things. So 1, 2, 3, 4. So basically I'm filling in these 4 blanks. So my height is 3, right? And then my distance in between those two things is 1. So I'm going to do 3 times 1. My next height is 4, and my distance in between is going to be 1. My next height is 7, and my distance in between is 1. I'm missing something. N equals 4, 0. So this would be the height 3. This would be the height 4. This would be the height 7. This would be the height 12. So my distance, oh, I still have to have the 4 on there, even though I'm not getting that height. My distance and my height is 12. My distance in between is still 1, because I still have this last rectangle to take care of. Now, it won't always be 1. In Delta Math, it's probably going to be a decimal point number, so you're just going to have to extend this idea to that. So it would be 3 times 1 plus 4 times 1 plus 7 times 1 plus times 12 times 1, which is going to be 26.